Using the same AI, why does your AI only hold casual conversations, while others' AI can actually complete practical tasks? The answer is straightforward. AI agents. An AI agent can proactively invoke external tools to finish tasks on your behalf. Today I will break this down in plain, easy-to-follow language. By the end of this video, you will grasp what an AI agent is, what it is capable of, and how you can utilize it. Products such as Hermes, Cloud Code, and Gemini all fall under the category of AI agents and serve as typical examples. So what exactly is an AI agent? To put it simply, an AI agent refers to an artificial intelligence that can autonomously call external tools to fulfill your tasks. Ordinary AI models are limited to chatting only, whereas AI agents can execute tangible work. You will notice this obvious gap once you get hands-on experience with one. For instance, Cloud Code and Codex specialize in code generation. They can independently break down task steps, invoke corresponding tools, and run automated tests. Tools including Hermes and similar agents support image generation, video production, document creation, data analysis, and many more functions. What distinguishes an AI agent from an ordinary chatbot? A regular chatbot is merely capable of verbal responses, whose knowledge base is formed entirely during training. You ask a question, and it returns a corresponding reply. That is the full extent of its function. AI agents operate differently. They can carry out conversations as well as take practical action by proactively invoking tools to complete assigned tasks. Here is a simple illustration. If you ask Doubao, "What's the weather today?" it will directly output a straightforward answer, seemingly identical to an ordinary chat. However, most people mistakenly assume it replies based on built-in memory. This is not the case. Behind the scenes, it invokes a dedicated weather service tool to fetch real-time meteorological data before organizing a response for you. I even inquired about its internal workflow, and its reply went as follows. I called a weather tool, retrieved up-to-date weather information, and compiled the data into a response. Users only see the final output, with the whole tool invocation process hidden from view. Tool invocation is split into two primary types: explicit invocation and implicit invocation. Explicit tool invocation means the entire operational process is visible to users. Take AI Code Assistance as an example. You can expand its reasoning panel to observe the full workflow, including analyzing requirements, selecting appropriate tools, and executing each step sequentially. Occasionally, it will even state prompts like, "I am checking real-time weather," letting you witness the tool running live. Implicit tool invocation works the opposite way. All operations run automatically in the background without any visible traces to users. Just like using Doubao, you cannot view its reasoning logic and are only presented with the final answer. How does an AI agent operate internally? Its complete workflow consists of 4 core stages and 5 specific steps. Step 1. Comprehend user requests. When users submit a task, the agent first identifies core objectives, defines task scope, sorts out restrictive conditions, and clarifies expected deliverables. It cannot deliver accurate results without fully understanding your demands. Step 2. Reason and formulate execution plans. Based on your requirements, the agent splits complex tasks into subtasks, matches applicable functional skills, selects required MCP resources and supporting tools, then drafts a complete execution scheme. Step 3. Collect contextual information. It retrieves relevant documents, reviews historical dialogue records, stores conversational memory, and supplements external reference knowledge as needed. Step 4. Execute operational commands. The agent calls standard MCP tool interfaces, leverages matched functional skills to conduct specific operations and collect generated results. Step 5. Verify and optimize outcomes. After task execution, it checks whether the output meets your preset goals, adjusts content where necessary, and reruns partial steps if required. As shown in the diagram, 3 core components support the whole system: MCP, skills, and context. MCP acts as a connector, linking agents to external tools, APIs, and databases. Skills serve as the agent's functional library, covering search, computation, copywriting, data analysis, and code execution. Context stores memory and associated background information, enabling the agent to accurately understand scenarios and make rational judgments. To sum up in one sentence, an AI agent is a combination of a large model core, external toolsets, and persistent memory, which completes full tasks following standardized workflows. The 5 steps together form a closed-loop execution process, and the 4 core stages, comprehension, planning, execution, and delivery, are closely interconnected. The streamlined logic of its workflow can be summarized as 1. Fully understand user demands. 2. Conduct in-depth reasoning and planning. 3. Execute tasks via tool invocation. 4. Inspect and optimize generated results. 5. Deliver finalized outputs. Many viewers may wonder, why do AI agents rely on such a wide range of auxiliary tools? The core reason is that large language models are not omnipotent. Even powerful models represented by GPT have 4 inherent limitations, which can only be remedied by 4 supporting modules: context, tools, skills, and MCP. Let's break down each limitation and corresponding solution. 1. Outdated knowledge cutoff. Models are trained on static historical datasets with fixed knowledge deadlines, lacking access to real-time news and live data. Therefore, internet search tools and external knowledge bases are essential to capture the latest information. 2. Limited to text output, incapable of independent operations. Standard models can only generate text content, with no ability to book flights, run code, or manipulate software autonomously, a problem solved by external tool integration. 3. Insufficient professional depth. General-purpose models possess broad but shallow knowledge across all fields. When handling specialized work such as coding, data analysis, and PPT production, dedicated professional tools deliver far superior performance, hence the need for targeted skill modules. 4. Isolated tool interfaces. Every piece of software and service adopts exclusive independent interfaces, preventing cross-tool communication. MCP solves this issue by providing a universal unified communication protocol. You can regard MCP as a universal adapter. Any software, hardware device, or API compatible with the MCP protocol can be seamlessly connected and invoked by AI agents. From demand comprehension and strategy formulation to task execution and result delivery, the 4 stages create an unbroken closed loop. Context, tools, skills, and MCP each bear unique responsibilities. These modules are not mutually exclusive. Instead, they complement and support one another. Without these auxiliary components, AI agents cannot produce stable, consistent results, and their performance will fluctuate randomly based on luck. Let's compare 2 practical application cases to highlight the gap. Case 1. Drafting weekly work reports. Ordinary chatbots only output generic universal templates. By contrast, AI agents can read your project progress data, analyze business indicators, and automatically generate complete reports embedded with data charts and visual graphics. Case 2. Code development. Basic large models merely output fragmented code snippets. AI agents will write source code, run the program, conduct functional tests, debug errors, fix defects, and finally hand over fully operational finished code. Cloud Code is a typical mature AI agent application. It does not merely generate text content, but realizes a full task closed loop through continuous tool invocation. In conclusion, AI agents are far more than simple chatbots. Their core capability lies in proactively invoking tools to accomplish tangible work, which marks the fundamental dividing line between AI agents and traditional conversational AI. All auxiliary supporting technologies exist to offset the inherent flaws of large language models, and none can be omitted. Looking into the future, AI agents will evolve into personalized super AI assistants for every individual. The key lies in mastering their underlying logic and learning to utilize them properly.